So, second order derivatives, hit pause, get the lesson objective down. Once you're done, we're going to look at some notation. Okay, so when we differentiate a function, we find its gradient, or the rate of change of the function. So that tells us if it's an increasing function or a decreasing function. When we differentiate it a second time, then we look at the rate of change of the gradient. So what's happening to the gradient? Okay. So with notation, we sometimes write our functions as f of x or y. When we differentiate in the first instance, we get f dash of x or dy by dx. When we differentiate it a second time, we get f double dash of x or d2y over dx squared. Okay, this is also written as, or well, also known as d over dx times dy by dx, which is where your d2y over dx squared comes from. So hit pause, make some notes. When you're ready, hit play again. Right, so we've got to find the first order derivative and the second order derivative of this function y, which is equal to 3x to the power of 5 plus 4x squared. First, I'm going to rewrite this as y is equal to 3x to the power of 5 plus 4x to the power of minus 2. Much easier to differentiate. So let's find its gradient, dy by dx. That's given by 5 times 3, which is 15, x to the power of n minus 1, or 4. Now this is going to be negative because I'm going to multiply by the minus 2, so it'll be minus 2 times 4, minus 8, x to the power of minus 3. Be careful. You take one away, it becomes smaller. And then the second order derivative, or d2y over dx squared, is given by 4 times 15, 60, x to the power of, take 1 away, 3. And because I'm multiplying by negative, this becomes positive. And 3 times 8 is 24, x to the power of minus 4, because remember we're taking 1 away, making it smaller. Let's just rewrite that. That's fine, I'm happy with that. Or you can write it as 60x cubed plus 24 over x to the power of 4. Either way, I tend to prefer this, but you need to be aware of this as well. Okay, good. Hit pause, write the example down. Once you've done that, hit play, and we'll look at one more example. Okay, so for this example, we're just using slightly different notation, that's all. We've got to find f dash of x, or dy by dx, and f double dash of x, or d2y over dx squared. So, first I'm going to rewrite that, make it easier to differentiate. F of x is equal to 3 square root of x, x to the power of a half, plus a half, x to the power of minus 1. Right, let's differentiate it in the first instance. That gives me multiply by a half, so that gives me 3 over 2. X to the power of, take 1 away from a half, minus a half. This is going to be negative because I'm multiplying by that minus 1. So minus 1 times a half gives me minus a half. X to the power of, taking 1 away makes it smaller, minus 2. Now the second order derivative, f double dash of x, or d2y by dx squared, is equal to, so multiply by minus a half, so you get minus 3 over 2 times minus a half, minus 3 over 4, x to the power of, take 1 away from a half, minus 3 over 2. Got a minus 2 times minus a half, so you got minus 2 times minus a half, gives me 1. So it's going to be plus x to the power of, take 1 away, minus 3, becomes smaller. can rewrite that, that's fine, I like that. And we can rewrite that as equal to minus 3 over 4 x to the power of 3 over 2 plus 1 over x cubed. Okay, so hit pause, make some notes. Once you've done that, I've got some classwork for you. Okay, and it's just the 4 questions for you today, taking no time at all. Good luck.